Hey guys, welcome to Impact. So we have been looking at UPSC Mains 22 in parts. GS2 is also going on. SA was completed. So GS3 already 2 parts are gone, and internal security was completed earlier. So we are here looking at the last part of GS3 questions. So the major bunch that is present here is science and tech and environment. So each year a large amount of plant material is deposited on the surface. What are its natural processes this cellulose undergoes before yielding carbon dioxide, water and other end products? So while per se the question appears very technical, if you take a step back and you look at the question, this is nothing but a part of the carbon cycle. Now, why they are asking about carbon cycle? Carbon cycle is most important because global warming, climate change, everything is based on the imbalance that we are creating in this carbon cycle. Hence, what they are asking is one part of the carbon cycle. Carbon dioxide is trapped by the plants. It does photosynthesis and it produces carbohydrates. Once carbohydrates are produced, then again cellulose is formed. Cellulose is being eaten up by the other organisms of the trophic level and it moves up the chain. So here they are particularly asked what are the natural processes the cellulose undergoes. That is especially the cellulose which is deposited on the surface of planet Earth. If the plant becomes dead or if it is falling out as leaf litter, so what happens? It undergoes decomposition. And who does this decomposition? It is a microorganisms like saprophytes, bacteria and fungi. They undertake this decomposition. So you can talk about that. If it is happening in the presence of oxygen, it yields carbon dioxide. If it is taking place in the absence of oxygen, it gives out methane. In addition to that, you can also talk about how this varies in the latitudes. It is very high in the equator, however, it is washed away also. It is very poor in the cold latitudes because there is not enough heat for the decomposition to happen. So the material will be decomposed very slowly. You can talk about that variation. But one very significant value addition that can be done in this answer is you can talk about carbon cycle, how we are disturbing this carbon cycle and the result of what global warming, carbon emissions, global warming, and all that has happened, and also some of the steps what is being done to mitigate that. Moving on to the next one. Photochemical smog, its formation, effects and mitigation, and also the Gothenburg Protocol. Once we see the name smog, the thing that we get is the smog that happens in and around Delhi, stubble burning, anticyclonic conditions, smog forms, 3 months breathing difficulties will be there. However, the question is not that. That smog which we were talking about is classical smog. It happens in the winter conditions. Photochemical smog happens in summer in presence of sunlight. Nitrogen oxides and volatile organic compounds are released, especially in internal combustion engines. They react with sunlight and they form a secondary pollutant, which are ozone and peroxyl nitrate. Now, ozone is good in stratosphere, but is bad in the lower troposphere. So what happens when these secondary pollutants are formed? We have cancer, we have breathing problems, kidney problems, neurological problems when we inhale all this. It also affects the plants, it affects their photosynthesis. So these are some of its effects. Now, how can we mitigate it? Again, this is not only released by the internal combustion engines used in vehicles, it is also released by industries. With respect to industries, we still do not know because the scale of industries is very wide. The process they use is varied, they are different. We do not know how, particularly if we have any particular alternatives for all those processes, or that may take time. Some of the immediate remedial measures that we can do is switch over to electric vehicles, switch over to hydrogen fuel cells, use a lot of CNG or CNG buses, which is currently being used in the capital. In addition to this, improved pollution control norms, for example, catalytic reduction, which has been made mandatory in all BS6 vehicles. So we can talk about that. So they are some of the mitigation measures. Then we have to explain the Gothenburg Protocol. So what is a Gothenburg Protocol? It is a part of the Convention of Long-Range Transboundary Air Pollutants. So we have to mention this convention. And what does the protocol aim at? It aims at reducing acidification, eutrophication, and ground level ozone. So we can explain few more points on these are the main points. You can add some more points to it and you can complete the answer. Again, it's a direct question and there's nothing difficult in interpreting or all that. Formation effects, mitigation, and a protocol. Next one, cloudbursts. So again, this question was expected few years back also. Because cloudburst has increased in scale. So again, if you're taking and reading articles based on cloudburst, you will find that across the globe, the incidence of cloudbursts have increased and people have told climate change is to be blamed for that. So introduction, how can we write the introduction? One of the cloudbursts which happened in Himachal recently, we can talk about that, or we can talk about the 2013 Uttarakhand floods. We can tell so much amount of life and property was lost in this floods, which was again caused by a cloudburst. Then we'll move on to the mechanism and occurrence. First, we have to write what is a cloudburst. So as per definition, if in a 10 into 10 square kilometer area, if we are receiving 10 centimeter of rainfall in 1 hour, we will call it a cloudburst. Again, if you are receiving 5 centimeter in half an hour, that also qualifies. So this article was given in Indian Express, explained based when this cloudburst was happening and all. So if you had read that article, you would have directly picked the points from that article for this answer. Now, how does it occur? What is the mechanism for its occurrence? Imagine a cloud which is moving up the slope of the mountain. So it's at significant height. Raindrops have started forming, but they are not yet heavy enough to come down, but they are slowly growing. Suddenly a hot air comes, it pushes this entire cloud patch up. And when it is pushed up, these rain droplets become bigger and bigger in size. Now this goes on until two things. Either raindrops have become very heavy that hot air cannot carry, or hot air becomes weak enough that it cannot push the raindrops further, or it's a combination of both of these processes. When that happens, the entire amount of rainfall suddenly falls or comes down in a very quick short span of time. That we will call it a cloudburst. So this is its mechanism. Occurrence, where does it occur? It occurs majorly in the mountainous regions. You can quote Himalayan region as an example. However, it cannot be ruled out in the plains also. That is about its occurrence. Two recent examples, you can again talk about Amarnath, which was because of a cloudburst. Recently, a pilgrimage, everything stopped. Or you can talk about Uttarakhand. So when we are discussing these, we can also touch upon the other disaster management aspects also. So what was the life lost? So what can we do to prevent it? So the problem with this aspect is, or this disaster management is, we cannot predict exactly a cloudburst. All our models, mechanisms, instruments, they are all aimed at predicting an event at a larger scale. Districts, group of districts are much larger. But a cloudburst does not occur in such a large area. It can occur in a range of mountains or in a series of ranges of mountains. It's a very localized phenomenon. While we can predict this region might have heavy rainfall, very heavy rainfall as per their scale, it is not exactly possible to predict a cloudburst. This makes it difficult. Then how can we manage it? We can manage it using floodplain zonation, making sure there are embankments built along the floodplains. There are no developments happening along the floodplains. So all that we can write. So that also you have to touch in this answer. Next, integrated farming system, a question that was much expected and it has been in the news for a very long time. What is an integrated management system? It is doing agriculture based on the principles of interdependence, resource efficiency, and recycling of nutrients. For example, instead of growing a crop, a farmer will have a pond, he will do aquaculture. The water from the aquaculture will have a lot of fish wastes in it. That is a very good fertilizer. This water will be used as a water for the plants. Whatever plants they are producing, some of it will again go as feed into the fish. So like this, a chain will be built up wherein the waste of one particular process become the input for the other process. Thereby nutrient cycling happens, resource is very efficiently used. So this is integrated farming system. Now, how is it helpful to small and marginal farmers? It simply increases yield. When it increases yield, it increases income. Now, if one crop is failing, livestock will provide him a support. If livestock is failing, poultry will give him support. If poultry is failing, crop and aquaculture will give him support. So he gets a sustained income. When he gets a sustained income, he won't get caught in the debt trap. Now, with this process, if he is doing it efficiently, his fertilizer usage and pesticide usage will come down multifold. Hence, the need for even getting a money or getting a debt is thereby greatly reduced. So the farmer can simply be much more prosperous in the system. On the whole, it is also environmentally sustainable. Over a longer period of time, the land won't yield or the fertility won't go down. It will retain. So these are some of the things. In addition to this, we can talk about one or two government schemes which aim to promote this integrated farming systems. There are a lot of demonstration projects happening in order to promote this. We talk about one or two such schemes, and you can conclude your answer. Next, the James Webb Telescope. So of late, we can see in the last 5 years, UPSC has asked questions. Usually they used to do in prelims. Now they have asked questions in mains about NASA's interplanetary missions or any significant achievement that NASA has been doing. For example, they asked about Juno, I think in 2018 mains, asked about the features of the mission. So this question is on similar lines. So what is this? It is a telescope. The project started in 2000. It was launched only in 2021 at so many delays. It's a joint project of NASA, ESA, and Canada, Canadian Space Agencies. So that will be your introduction. What are its unique features? One, it can see in IR. The earlier telescopes cannot see in IR. They can see only in UV and visible. Hence, an entire spectrum is being opened up with this telescope. Number two, they have been located. This is located in the Lagrangian point 2, that is between the Earth and the Sun. Now, earlier telescope Hubble was in a low Earth orbit. Now, when Hubble was in a low Earth orbit, the rotation revolution of the moon, moon and rotation revolution of Earth, Hubble will be somewhere coming in and around between the shadow zones of Earth and moon. Now, this telescope is, when it is coming in the shadow zone, it cannot view the space. Now, this telescope, unlike that, can view the space continuously throughout the day, no disturbances or hindrance of any sort. So that is another great advantage. Next is the area that it will be covering, that is much larger than the Hubble telescope. Plus, this can also see events which happened 13.3 billion years ago, whereas Hubble can see events up to 12.5 billion years ago. Next, it's sunshade. So any objects radiates radiation or emits radiation. The IR, especially since this is an IR camera also, it has been designed in such a way that the sun's radiation as well as the satellites or the telescope's own radiation will not affect the measurement of this system or of the telescope. So these are some of the features. This only if you had read it, you will be able to understand. But look at the next two parts of the question. Key goals and potential benefits does it hold for human race? Key goals of this mission is simply exploration, in that you can add 2 points to find out exoplanet, to find about the birth of stars and all that. You can write a lot on that. Now, what potential benefits? Again, it is a much broader question. It's up to you and your creativity to write this. We have a lot of theories which can be confirmed with this observation. We can actually see, things that happened right after the birth of the universe, formation of stars, what has happened since then. Everything that we can prove. Next, if it's finding any exoplanets, if it is finding any life, maybe it might even be a human colony in the future. So this is part of the question, is up to you and your creativity to write. It's a very broad area. Next, principles behind vaccine development. So this we know. The first part is very easy. How does a vaccine work? You introduce a dead organism or live organism or something, our body fights it. Next time when an actual organism is coming, which is a strong organism, a live organism is coming, our immune system will know how to fight that. So that is a principle. Now, how do they work? There are different types of vaccine. If you are looking at the different types, you will see how each one works. For example, one in which we can directly introduce the organisms. Now, that organism can be alive and weakened, or it can be completely dead. Both will elicit an immune system response. Or we can use genetic material. Just remove the DNA, RNA material, insert it in our body. It will use our body to produce its protein. that protein will evoke our immune response. So this genetic material can be either DNA or it can be RNA. Next one is a subunit approach. So in a subunit approach, a part of the protein or any other part is taken and introduced in our body, which will again elicit an immune response. That protein alone will be there. It will not contain any genetic material or not. So recombinant conjugate, there are several more types also. You can mention at least one or two here, and you can tell in general how they work. Next, approach of Indian vaccine makers. So particularly they have asked Indian vaccine makers. So we have had 3 Indian vaccines. Covaxin, which is based on inserting a dead organism in our body. Covishield. Now again, Covishield is not a coronavirus at all. An adenovirus has been taken. It has been genetically modified so that its spike protein or protein resembles that of a coronavirus. It has then been introduced in us. It is a live and a weakened organism. Next, the Zycode DNA vaccine. That is world's first DNA vaccine. Not only for coronavirus, for any disease, it is the world's first. So look at the strides that India is making in vaccine development. So DNA will enter into our body, DNA will produce RNA, RNA will produce proteins, which will elicit an immune response. So we can write about all this. Maybe in the conclusion, you can write about how India had helped the other countries in exporting vaccines, even when all the developed countries refused to do so, or their effort was minimal in that direction. In spite of we being a developed country, you can talk about some of the efforts that we had done, or in other ways, we can talk about how we can be better prepared for pathogens of the future. So that is up to you, how you are finishing the answer. Next, global warming, a very simple question. We won't be discussing this. So what is global warming effects measures to bring down the level of greenhouse gases? In light of Kyoto Protocol. So Kyoto Protocol, again, it's a very common area. So you have to know that in 1997 it was signed, 2005 it was implemented. It is based on common but differentiated responsibilities, wherein developed countries were pushed more to take targets. And these mechanisms were done: clean development mechanism, emission trading, and joint implementation. We won't discuss them in detail. And you can talk about this, you can talk about Doha Amendment. In addition to do some more value addition, you can talk how this evolved over a period of time. Because Kyoto Protocol did not work very well. Some of the countries pulled out of this agreement. So what was the end stage, whether it was able to achieve its goals completely, or what was the lacunas. We can talk about that. Then we can also mention a few lines about Paris Agreement, what is its goal and what state it is currently in, as in the conclusion. Next, coastal erosion. So on coastal erosion, there was a PIB article. So this first fact is taken from that, which says that at least 35% of the land is taken, or it's under varying degrees of erosion. We can use this fact as an introduction, then we can tell what is coastal erosion. Then we can go on to the causes. So causes are 2, man-made and natural. Naturally, the process always happens. In one part it is eroding, another part it is building. But leaving that out, we have also done a lot of things to accelerate this process. For example, port infrastructure, reclaiming islands, sand mining, or other forms of tourism infrastructure or road infrastructure, thereby disturbing its balance, destruction of mangroves and wetlands in these areas. So these are all man-made causes of how we are promoting an acceleration. So what are its effects? Coastland is a unique ecosystem because it has, on one side it is the end of the land, on the other side it is the beginning of water. There are some organisms which survive only on the coast, especially if mangroves and wetlands are there along the coast. They form very rich and also unique habitat for a lot of species. So all this will be destroyed. The area will be prone to disasters. From an economic point of view, aquaculture will be affected, tourism will be affected, and even when sand is taken out, sand actually acts as a buffer between the seawater and the freshwater table. When we are removing more of this more of sand, chances are that seawater will come and intrude into the freshwater table and make it unusable. Now, how can we manage this? Sustainable development, coastal zonation. We already have this. Enforcing it, making all development sustainable. ensuring, and if in areas of accelerated erosion, we can ensure some hard erosion control methods. What can this be? For example, we can have a sea wall. It is a very costly affair. Or you can see that sea walls have been erected in Andaman and Nicobar to prevent erosion. Similar small structures are there. One of the other such examples is having rocks so that they break the impact of the waves. For example, in Pondicherry coast, a lot of coast is being eroded. To break that, a lot of rocks has been put on the main beach in Pondicherry to prevent erosion. So those are again some of the other methods. So we can talk about all that and we can conclude the answer. That's all for this video, guys. In the upcoming videos, we'll be looking at some other areas. Thank you.